So is my audio clear? Okay, so can someone inform me in the chat if my audio is clear or not? Okay, so is my audio clear? Can someone tell me in the chat whether I am audible and my video is visible to you or not? Okay, so good evening, guys. This is Divyanshu here, and welcome to the C and C++ channel for Geeks for Geeks. And here I am with some questions, with some hands-on questions that are asked in the exams such as TCS NQT, and similar. So we generally stream from between 4 to 8, and we discuss in the streams we discuss questions that are generally asked in NQT, which belong to the topics such as verbal ability, hands-on question that are related to programming, and some questions that are of MCQ types also. So today I'm here and I'll be discussing questions, basically the coding questions that are asked in these exams. So let's move ahead and look at the questions that I have for you all. So the first question that I have for today's schedule is, okay, so today all the questions would be related to the strings. All the questions would be on strings only. Generally, strings and arrays are the two most favorite topics on which the questions are asked. So the first question that we would be today discussing would be palindrome strings. So in this question, given a string s, check if it's a palindrome or not. So in this problem, you would be given a string and you have to check whether it's a palindrome or not. So if it's a palindrome, you need to return 1, and if it's not a palindrome, you need to return 0. So let's see what should be the approach for this type of question. So the question is, is palindrome. So let's see first of all. So the question says you are provided with a string and you have to check whether this given string is a palindrome or not. So let's first discuss what's a palindrome. So palindrome is basically a string that is basically a palindrome is a string. If we reverse this string, so if I reverse this string and the reverse string is equal to the given string, then the string s1 is known as a palindrome. Basically it is equal to the reverse of the same string. So such strings are known as palindrome. Let's take some examples of palindromes. So a string like ABC, CBA would also be a palindrome, because if I reverse this string, suppose I reverse this string, so the string becomes A, B, C, C, B, A. And here we can see, if I say this string is S1 and say this string is S2, so here we can see that S1 is equal to S2. So that means this string is a palindrome. So let's see one more example. So let me consider a string that is A, B, C, D, E, F. Okay, so now I'm going to reverse the string. So the reverse of this string, let's assume this S2 becomes F, E, C, F, E, D, C, B, A. Now here we can see that S1 is not equal to S2. that means the given string S1 isn't a palindrome. So a very basic approach to this question, could be, we can take the given string S1 and then reverse the given string S1 and store it into a new string S2, and then compare. If S1 equals to S2, then if this comparison results into a true, then this means this is a palindrome. If this results into false, that means this is not a palindrome. So this is the very basic and then naive approach that we could use. But if you went through the question, if you read the question thoroughly, the question says that expected auxiliary space should be big O of 1. Now in the approach that we just discussed, here in this approach, the auxiliary space or the extra space that we are using is equal to extra space that we are using in this approach is equal to big O of n. And the reason behind this is that we are making copy of this S1, a reverse copy of this string S1, and storing it down into the string S2. That means a big O of n extra space is being used. So though it is a good approach, and this would perfectly bring the answer to our question, but this is not exactly the algorithm that we want. According to the question, this is not the exact algorithm that we want. So let's try to make some observations and see how we can optimize this space complexity to big O of 1, or that is something known as no extra space or no auxiliary space. So let's make some observations. So some observations that we can make here is that whenever we are comparing, so in a naive approach, what we were doing, we were just taking the string, reversing it, and then comparing each of the character by character, and checking whether it is equal or not. So if we just carefully observe, so let me take this example. So if we carefully observe, we are comparing the character A with character F, then we are comparing character B with character E, then we are comparing character D with character E, and if any of them results into a false, that means the string is not palindrome. So the comparisons that are happening is between the character A and character F. So if we look into the same string, what we can find that character A is being compared with character F, character B is compared with character E, and character C is being compared with character D. That means if we look into the same string, this character is compared with this character is compared with this character, this with this, and if any of the one comparison results into false, that means this is not a palindrome. Similarly in these examples also, we are reversing the string and making comparison between this A and this A, that is something like this. We are making comparison between this B and this B. We are making comparison between this C and this C. So that means we can find whether a string is a palindrome or not by comparing into the same string. Okay, so let me take this example and explain this approach further. So So just a second, let me clear the board. Okay, so let's see between what positions the comparison is actually taking place. So let me write a string here, that is A, B, B, A, B, B. Okay, so just a second, A, B, C, B, A. So let's suppose this is the string that is given to us, and the comparisons that are made are between first A and the last A, B, this B and this B, and this C obviously with this C. So if we see on zero-based indexing, if you use zero-based indexing, the comparisons that are made is between the first position, that the 0th character, and n minus 1th character. If n, let's assume that n is the size of the given string, so the comparison is made between the 0th character and n minus 1th character. The second comparison that is made is between the first character and n minus 1 minus 1th character. Similarly, the next comparison that is being made is made between the second and n minus 1 minus 2th character, that is the C itself. So these are the comparisons that we are making. So if I start from I is equals to, okay, so the total number, what are the total number of comparisons that are making? If the length of a string is n, the total number of comparisons that we are making here is n by 2. Here we can see the length of so exactly n by 2 comparisons are being made. So basically what we are doing is we are starting from I is equals to 0 and I is going till I is less than n by 2 I plus plus, and we are basically iterating from I is equals to 0 to I is less than n by 2. That means it's a loop. And the comparisons that we are making is s of the iterator that I am using is I, so this becomes, at I is equals to 0, this becomes I is basically currently 0, and so I can write this as n minus 1 minus 0, so that's basically something equal to n minus 1 minus I. So the comparison that we are making is between s of I and s of n minus 1 minus I, and if at any point of time during this iteration, during this n by 2 iterations, this s of I is not equal to s of n minus 1 minus I, that means the given string, so if s of I is not equal to s of n minus 1 minus I, so the given string is not a palindrome, and when the given string is not a palindrome, we need to return 0. So what I will do, I will return 0 from here. If s of I is not equal to s of n minus 1 minus I, it simply returns 0. If this loop completes and this condition is never hit, this simply means we need to return 1. That means the given string is a palindrome. So here, as we can see, that no auxiliary space or extra space is used. That means we have reduced our space complexity to big O of 1, and that was what was expected by us in the question. So let's move back to the question and try to write the code, try to code it. Okay, so let's try to code it. So the string that we are having is in the variable s. So first of all, let me calculate the length of the string, that is size. Okay, so here I can use size, or even I can use length here. So let's go with size. Okay, so let's write the for loop. Let's now write this for loop that we just discussed. For int I is equals to 0, I is less than n by 2, plus plus, if, now the if conditions that says if s of I is not equal to s of n minus 1 minus I, return. Okay, so if it's not a palindrome, we are supposed to return 0, and in case if this loop runs for n by 2 iterations and all the elements are equal, then return, then we would be returning 1. So that was the code that we generated. Okay, so yes, that's the code, I think so. So let's compile. Okay, so for the string that is ABBA, your output is 1. So basically ABBA is a palindrome and we are getting output of 1. So let's okay, so let's try to submit this. Hope so this works. Okay, so correct answer. Okay, so this code basically executed and we are able to find palindrome of a given so this code basically executed and we are able to find the palindrome of whether the given string is palindrome or not into a space complexity or expected auxiliary space of big O of 1 and time complexity big O of length of s. Basically this loop is iterating for n by 2 iterations, but asymptotically it's linear, so it won't cause much difference. Okay, so that was our first question. Check whether a string is palindrome or not, and we have achieved this. So let's okay, so GFG is also having a test series that is completely related to TCS NQT, based on TCS NQT, and here it is, TCS NQT mock test series. So this is a series especially for NQT aspirants who are trying to score good in TCS NQT. So this series is on GFG, available on online course in the online courses section. So it has 2000 plus questions, 55 plus mocks, and various other features that are just very good for preparation of such rounds. So if anyone is interested, he should just have a look and give it a shot. So okay, so let's move to our next question that we have. Okay, so let me just clear the screen first. So the next question that we have is also a very interesting question, and it sounds quite simple, but it's quite interesting. Okay, Okay, so let me select a pen. Okay, so let me see the chats. What do you have? Okay, so let's see our next question that we have for today. So the next question that I have is reverse words in a given string. So the question goes like, or the problem statement goes like, given a string S, reverse the string without reversing the individual words. Words are separated by dots. So basically what we need to do into this problem is that you are given a sentence. Basically we can say that in much easier terms. You are given a sentence and you need to reverse that sentence, basically what this problem is trying to say, and each word is separated by a dot. So for example, if input says I like this program very much, so the output becomes much very program this like I. So basically you need to reverse the sentence. Okay, so let's see what should be the approach for solving such question. Okay, so let's see what the input is. So we are provided with the input, that is a sentence. Okay, it's the input. So it's a sentence, like let's just take the example that's given. I love programming, I'm writing the short form, very much. So this is the input that's provided to you, and the output that you need to generate is something like much, very programming, love I. So that's the output that we need to generate. Now I remember for the first time when I saw this question, it was long back, exactly I don't remember when, but for the first time when I came across this question, so what I did is I took this, let us suppose this is string S. So what I did is I just returned, I did this, so I just returned reverse of S, assuming that this would just perform the thing that is needed, would reverse the sentence, and that would just do that, and that would just do well. But actually what happened, this gave a wrong answer to me. Actually what happened when I did reverse of S, so let me write reverse of S here. So when I did reverse of S, what exactly happened was the string that I got was was something like 𝙎𝙤𝙘𝙞𝙡𝙤𝙀 GeeksforGeeks.𝙤𝙤𝙀.𝙎𝑉𝑜𝑙.I. So this was the string that I got, and of course that is not at all equal to the output that we want. So basically what I did at the first sight was basically wrong. So it was long back. So basically what I did, I returned this, but actually it's not the output. So let's see what exactly the output is and what exactly the output is demanding. So here we can see that the output, this much comes at the first place, this very comes at the second place, program comes here, love goes there, and I comes at the last place. So basically what we can observe from this is that this word reaches the first place, and here in reverse also we can see that the word much has reached the first place. Okay, so just let me clear this one, it will be easy to, okay, So here we can see that the word much has reached the first place, but it's into the reverse order. Similarly, the word very has also reached to the second place. The word prog, prog, has reached to the third place, but it is in reverse order. Similarly, the word love has also reached to the first, second, third, fourth place, but it is also in reversed order, and I has also reached on its place, but it is also in reversed order because it's a single character. That's why you can't see whether it's reversed or not. So that means reverse of S, in reverse of S, every word has reached on its place, but the order of the word, every word has reached on its place, but the word has reversed itself. Like much has reached its place, but it is basically written in reverse order. So in this program, what we need to do is, we need to first of all, of course, reverse the given input, then we need to find each. Okay, so I'm really sorry for the disruption. I don't know why my whiteboard just stopped working. So yeah, so we were discussing this question, so let's continue. So the question was that we are given with a sentence that is something like okay, just a second. So we are given with a sentence that is something like, I love prog very much, and we have to generate output that says much, very, prog, love I. So basically this was the input provided to us, and this is the output that we have to generate. So what I was telling you, that the first step is that we need to reverse this given string. So reverse of S would be equal to, okay, so reverse of S would be equal to 𝙤𝙤𝙘𝙤𝙤𝙤 dot 𝙤𝙤𝙤𝙤 dot GORP dot 𝙤𝙤𝙤𝙤 dot I. So that would be the reverse of the given string. So the first step that we need to do is we have to reverse a string, and then what the observations that we made was that we have now got our words on the right position. Like much, here this is much, and here also this is much. The only difference between them is that this much is in the correct order and this much is basically in the reverse order. Similarly for every word actually into this reversed string has reached to its actual position. The only problem that we are having is they are in reversed order. So what basically we need to do in this question, we need to we need to just gather, or we need to just find every word and then reverse it. And we know that words are separated by dot. So this means whenever we will encounter a dot, this would mean that a word just ended before the dot and the next word starts from next position of the dot. So let's try to, okay, oh, it's present here. Okay, so let's continue with this one only. So what we got to know that, okay, so let me clear this one out. Okay, so just a second, let me clear this all out. Okay, so what we got is that, okay, so what I was telling, that if we encounter this dot, that means a word just ended before the dot and the next word start from the next position of the dot. So this means, okay, so for generating each word or reaching each word, we need to iterate from I is equals to 0 till I is equals to n minus 1, where we suppose that n is equals to, if it's string s, then string s dot length, or I could write size also here, that's also right, that also works perfectly fine in C++ because they are part of STL. So I have to iterate from I is equals to 0 to I is equals to n minus 1. So let me put a loop first of all for int So actually I'm facing some technical glitches, so let's directly dive onto the code. So the approach that I just told you all was, what we are going to do, we are first of all we are going to reverse the string. So first of all, let me just calculate the size or the length of the string. So okay, so the next thing that I'm going to do is I'm going to reverse this given string. So reverse s dot begin comma s dot end. So this would basically reverse the given string that I have. Then we need to iterate from I is equals to 0 to I is less than n, I plus plus. Then okay, so we need to keep the track of starting of every word. So let's assume variable st, and that's initially pointing at the starting of the initially pointing at 0, that means starting of the first word. That is currently st is pointing currently st is pointing to the start of the first word. So okay, so let's write the condition. So what we actually have to do, we have to find the So actually what we have to do, we need to find the dot into the string, because the dot would mark the ending of the last word and starting of the next word. So what I'm doing is si, if si equal to dot. So whenever we encounter dot, this means that the last word has ended. So basically I is the position where the word has just ended, the word that we were having has just ended. So what we need to do, we need to reverse that word that starts from st and ends at this pointer I. So we need to reverse, what we need to reverse is starting from st. So what I will write is s dot begin plus st comma s dot begin plus I. And once this step has been done, now what I need to do, I need to update st to I plus 1. Now I will explain what the statement is exactly doing. So exactly what the statement is doing is initially st was pointing to the first to the starting of the first letter. So when we encountered a dot, so now st needs to point the starting of the next letter, and the starting of the next letter would be present at I plus 1th position, that is just next position of this dot. So that's what I'm updating. I'm now, after this statement, after this reverse statement has performed, we are updating st to the starting of the next word. So that's it. So by this much code, what would happen? By this much amount of code, what would exactly happen? That okay, let me try once again for writing. Okay, let me try once again. Okay, so let's say that he is a good guy. He dot is a good guy. So basically, when into the reverse string, when we will be performing the operations, and when we would reach on this dot, the st would be pointing here, and there is no dot further. So the loop would, the string, the answer that would be generated would be perfectly this much, but the last occurrence or the last word would be present into its reversed form only. So for example, I will just show you what exactly I'm trying to say. So okay, so let me try one thing. Let me print out what exactly okay, so let me return this to retu. So let me return the string s, and let's see what the output comes like. So let me copy this input, and let's see what output comes of this string. Okay, so there's some, okay, so this is capital S, I suppose. Okay. Okay, so that was basically for the first input. So let me see for this. Okay, so here you can see that the point that I was making here, what we did, we first reversed the string. So when we reversed the string, and word by word started to we collected each word and started reversing it, but the last word is still into its reversed form. Since we can see that in the output here it should be PQR, but it is RQP. The reason behind this is that this is the last dot that we encountered, and there is no other dot present here, so this reverse statement wouldn't go well for this last word. So out of the loop, what we need to do, we need to perform the reverse of the last word also by on our own, and that would be something like s.begin plus st comma, and basically now we have to perform the reverse for the complete string, that means s.end. Okay, so now let's compile and run it. Okay, so on my custom input. Okay, so now we can see that we have reached the output that we desire. So let's submit it, and hopefully it works well. Okay, so here we can see that it works completely fine and it says correct answer. So okay, let's do one more thing. Let me comment it down and then submit it. Let's see what happens. Okay, it says wrong answer. So yeah, basically the thing that I was saying, the correct output is this and we are getting this, and the reason behind this is that we don't have a dot here, so this part, the last word, doesn't gets reversed. We need to reverse it explicitly, so for that purpose only I've just used this reverse. So okay, so yes, so this was all for this stream. The two questions, these were the two questions that we discussed, and so this was all for the stream. We would just conduct these streams daily from 8 to 4 on different topics, on different sections of basically on different sections that are present in TCS NQT. So okay.